Hi, I'm Dr. Jacqueline Garner from Georgia Institute of Technology. Welcome to your Carbon Reduction Challenge project. I, along with some other faculty members, will be helping you with your project. In this video, I will be reviewing some of the financial calculations we need to make in order to justify your project from a business perspective. Let's get started. So when we make the business case, we're making financial calculations that show what the benefits of undertaking this project are for your organization and other stakeholders. It's important for all firms, both for-profit and nonprofit. So before we get started on talking about the calculations, let's talk about some companies that have made commitments to carbon reduction. Delta, for example, is expected to invest $1 billion on airline carbon neutrality solutions, and they expect sustainable aviation fuel, SAF, will play a key role in the decarbonization pathway. Cox Enterprises has goals to send zero waste to landfill by 2024 and to be carbon and water neutral by 2034. They will invest more than $100 million on sustainability. And Interface, a local Georgia carpet company, plans to be carbon neutral by 2040, that is, store more carbon in their products than they emit from their products. So the types of projects you can use and think about are four. First one, you can do something that would inspire collective change and personal behavior, such as a red meat challenge or bike to work. Two, you could shave energy use through a no-cost modification, meaning there's no upfront cost. For example, change a lighting schedule or HVAC boiler set points. Three, make infrastructure changes to a building's energy use, such as installing a cool roof, replacing light bulbs with LED bulbs, etc. And finally, making changes to the business model or operations, for example, selling more fountain drinks instead of single-use drinks, changing the restaurant menu to have a meatless Monday. Amazon might want to reduce their express delivery frequency, something like that. So when we make the business case, we're going to make three calculations. For all of the types of projects with the exception of one, the one that doesn't have an initial upfront cost will only be able to do the net PV. But the other three categories can make all three calculations: net present value, internal rate of return, payback period. But we also need to consider any co-benefits that result from your projects, such as increasing employee engagement or retention, better relations with the community, stronger brand recognition, and customer loyalty as a result of the company taking your suggestion. So let's do a simple example where a company wants to do an LED retrofit. So they're going to replace 500 fixtures that cost $700 a piece, so the total investment is $350,000. That will be an outflow to the firm. The firm pays that. But they expect by doing this, they're going to save 665,000 kilowatt hours. That's the energy savings, and the energy price is 15 cents per kilowatt hour. So the product of those two is $99,750. That's an inflow to the firm. Now that's a pre-tax savings, and we actually need to do after-tax savings, but we'll do that when we get to Excel. And then we're also going to have some depreciation benefits and more later on this. And we're going to assume we'll have these benefits for 10 years. So we've quantified a little bit here, but we need to make a couple of more quantifications. So before we go into a detailed example, let's look at a simple example. Okay, so suppose you were going to invest $100 at time zero. There's an outflow of $100 at time zero, and you were going to make an investment in something, and 1 year from now, you're going to get $115. So what we're trying to do is businesses make decisions where cash flows happen potentially in the future, like this 115. But the business decision needs to be made today, but that 115 is not in today's dollars. So what we need to do with that 115 is discount it, get it back to today's idea, today's value. So this simple equation here in yellow and blue, so we've got CF0, and notice it's an outflow. It's a negative. That's that minus 100. And then what's in blue is what you think it's worth. And we're going to discount. We say it discount. That dividing by 1 plus R is discounting. And we're going to discount it at your required return. And suppose for you that's 10%. So what we're going to do in the second equation, minus 100 plus 115 divided by 1 plus R, if R is 10%, 10% in decimal form is 0.1, so 1.1 to the 1. And notice that's worth 104.55. So you invest 100, but it's worth 104.55, that 115 in today's dollars. So you're up $4.55 in today's dollars. So how do you know whether you should accept or not? If you think the project is worth more in today's dollars, what's in blue, than the initial investment, what's in yellow, you would accept. And finally, another way to think about NPV, if NPV is greater than or equal to $0, accept. And because this is $4.55, you would accept. You have exceeded your required return in a dollar standpoint. So now let's look at a second technique for making the business case. And that's the internal rate of return. We're going to use the same simple example. So suppose you have an outflow of $100 at time 0, and you're going to receive $115 1 year from now. So the IRR, or internal rate of return, is the actual yield or return on the investment. It's also the R, the interest rate, that makes the NPV equal to 0. So if we see the same formula that we saw in the NPV calculation, NPV equals minus CF0 plus the discounted value of the future cash flows, CF1, through CFT, where T, if it's a 10-year project, would be the cash flow at time 10. So now in the second equation, I've replaced NPV with 0. I'm forcing the NPV to be equal to 0. So what we're also doing is we're forcing the market price, the initial investment, to be equal to the present value of the project's cash flows. So all I'm going to do in the third equation relative to the second equation is I'm going to add CF0 to both sides. So CF0 is now on the left-hand side, and it disappears on the right-hand side. And now if you look at that third equation, it's clear that we know everything except the denominator. We're solving for that R. What R makes this true? So if we put our cash flows in there, we're going to put 100 in as cash flow at time 0. And notice it's now a positive 100 because it was a negative 100 when it was on the right-hand side, but when we brought it to the left-hand side, we added it. So 100 equals 115, which is our cash flow at time 0, divided by 1 plus IRR. So effectively, we're saying if you invested $100 today and received $115 1 year from today, what return are you making? Well, that's 15%. We can sort of do that in our head. If we invested $100 at a 15% interest rate, we would receive $115 1 year from now. We can also do this in Excel, by the way. But what's the accept-reject decision? If IRR is greater than the weighted average cost of capital, and that's a new term, but what is that? That's the required return. And in the previous example, in the NPV example, your required return was 10%, or the firm's required return if we were talking about a firm. So in this case, the 15% is greater than or equal to what we require. So again, you would accept. So we've talked about NPV, we've talked about IRR, and now we're going to talk about payback. So what is payback? It's how many years does it take to recover the initial investment? This one's pretty easy, particularly in this simple case. So what we're going to do is we're going to take the 115 and we're going to divide it by the 100, not the negative 100, but just the absolute value of the investment. And what we're going to see is we're going to calculate 0.87. So what does that mean? It only takes a portion of 1 year to recover my $100 investment. So suppose revenues and expenses happened evenly throughout a year. A project that cost you $100 today and produced $115 1 year from today, well, you don't even need the full year to recover your initial investment. And as I mentioned here, it can be a little bit more complicated than this because generally you're not going to recover in such a short period of time. So you will need to include multiple cash flows and your payback may be longer than less than a year. But this is the idea of payback, big picture. And by the way, unlike NPV and IRR, payback does not have a clear-cut decision rule for accept or reject. So let me remind you, what's NPV's decision rule? Accept if it's greater than or equal to $0. What's IRR's? Accept if it's greater than or equal to the required return, also known as the weighted average cost of capital. Payback doesn't have a clear-cut decision rule. It's arbitrary. So we should be careful when we use payback, but we should also use it in conjunction with the NPV, which is the best metric of these three measures. So thank you very much, and we hope you enjoy your project, and we'll see you soon. Thank you.